Yo. If I turn my mic up too loud, it actually comes back. The audio comes through the mic, it seems like. Interesting. So we're streaming. We're streaming. Wonder if I can like... Which way would that be? Yeah, I kind of would like to be more in the center, but I don't want to like move more into the center. I'm actually trying to sign up for Twitter. I hate social media. I hate social media. Worst picture ever. I love how Elon Musk is the first person it says to follow. Yeah, I figured if I'm gonna stream, I should like put it somewhere. All right. There's also this other application I've been looking at lately. Minds. Yeah. Yep. I'm just kind of like... I know that the next thing we need to do... I think I did fix this. Next thing we need to do is test convolutions and test pooling. And I think I actually want to do the pooling first. This is gonna be interesting to see how we do this. And just to make sure all of this stuff works, let's go ahead and make sure we've done this first part right. Convolutions of pooling. Okay. So I always do like the hello world as my first initial functionality, I guess you could say. Okay. Make myself tiny, tiny. I know I'm being like super boring right now. I just kind of like totally got distracted I probably lost somebody because I wasn't doing anything. Somebody joined for a total of 30 seconds. But yeah, so sometimes I go through and I just want to close everything. And that's what I'm going to do, even though I know I'm going to have to work my way back out of this hole later. The first thing I want to do though is test pooling. And then we'll go to the definition. So here we're gonna have to so I'll be on YouTube. I mean, I'll be on Discord and stuff. And people ask me if I had got Twitch, and I'm only on YouTube. I'm kind of convinced that people only watch Twitch because, like, people only watch chicks on Twitch because they have boobs. Like, I've never seen a Twitch channel do really well unless the person on Twitch already had a good following with like Instagram or something else. I don't know. I'm honestly a bit out of it today. Today's been a pretty overwhelming day. I did a lot of nothing, and that can be exhausting. Hello, hey Kishin, did I say that right? I'm pretty much talking to myself half the time I'm on here, just because I know I have some friends that'll come back and watch this later. Anyway, I need to get started on this, or I'm not gonna finish it. First thing is to initialize the network. Did I ever set up a constructor? I want to create a CNN based on a template. My pleasure. Thanks for checking in. I don't really know how to make programming more engaging unless somebody just like literally just wants to talk, or unless they specifically want to know how something that I'm working on works. Do you have any ideas on how to make content more engaging? Feel free to tell me. So the first thing we're gonna do is we're gonna build the network, and then we're going to add a new layer. We're gonna set that to be a pooling layer, and we already have a pool initialized when we construct this. So let's just see that. We got a 2x2 non-discriminatory filter, and we can do max pooling. So we need a way to add an input. So let's go to the definitions. So, damn it, we actually need to go to the header. Okay, so when we construct a neural network, we have no input, so our input's set to 0. We have no input layers. I still don't like the way this is set up. Cause I keep number of input layers. This should be the number of layers per input. But I hate sorry, I had some work stuff come up. Number of input layers should be the number of layers per input. The number let's say that this is the number of this is the total of inputs that we have. And then this is the total of input layers. Just to keep things uniform, we're gonna put number of inputs total. Number of total inputs. And then number of input layers. So the layers should be the same. We don't want we don't want to compare. Maybe images are different size, but we don't want the layers to be the different size. So the idea is that this should be RGB and gray. Or that would be more accurate. I mean, it's RGB, but we want black also. Yeah. Anyway, I kind of lost my point here. So we're gonna need to set an input. It's the first thing we're gonna need to do, and we're gonna want to take in a tensor. The cool thing about this is that, so the idea here is that we could have, I don't even want to explain this. I don't want to explain it without a diagram, and I don't want to draw a diagram. I feel like I need to for my own mental sanity though. So like, our 3D tensor is essentially just the cube, where our image can be 4 layers. And this would be our red, green, and blue, and grayscale. But the thing is, with our tensor, we might want, do we have the option? We might want to package up each one of these. So the idea here is that this entire thing is our tensor. That's where these numbers come from. So this whole thing, this is the input. So in this instance where we have four, in this instance we would have the number of input layers. And see, this is why I don't like this. The number of input layers. You would think that's the number of, so it should be the number of input layers, the number of input samples, and the number of sample layers. That's a better description. Because in this instance, this entire tensor is our tensor of floats, and it's 3D. Why did I do that? Where our number of input samples in this case is 1, 2, 3, 4, 5. And then the number of layers, sample layers, is 4. So each, and really I could extrapolate these from the input data, because this is a 3D tensor. It almost becomes a 4D tensor. I could make it a 4D tensor. I don't think I want to do that. I'd rather keep it I mean, it is still 4-dimensional. I'd almost rather keep it 3-dimensional though. Where just to explain how it's 4-dimension, could be 4-dimensional for those who don't follow. This is our X dimension and this is our Y dimension, and then this could be our Z dimension. But this could be Z, and then this could be W. So this would be Z0, Z1, Z2, Z3, and so on. Which would give us another dimension. But we don't have to do that. See, I'd rather not get into the width and length of this. I'd rather just think that this is a matrix. Like, this whole cube is a single matrix, and then this is our 3D tensor. We're just going to keep pushing stuff into this tensor. Every time we increase the tensor, we'll increase the number of samples. So each one of these becomes a sample. and then each sample has a series of layers. So then we end up with a for loop where this is y and this is x. Even though this is y and this is x, that's why it could be a 4-dimensional. Is because if this is x and this is y, then the output of this will be a single image that also has a y and an x. So once we get a single input, a single image, we will still have to go through the x and y values of that. That's why it would be a 4-dimensional problem. And that's also why I want to keep it, excuse me, a 3-dimensional problem, because when we have this as a single list, we can actually put these two values together. So let's think about that real quick and make sure this works. The number of layers is the y-axis in this equation. So we should be able to say that our input, because even as a 3D problem, as a tensor, we're saying that this is our z, and then we want to get out of this z problem here an xy problem. From the z, we want a matrix. We want to get a matrix of floats out of our tensor to get a single image. So to calculate for z, we would say that z equals, if this was I and this was j, that it would be let me redo this. Let's do this in code. This might make a little more sense in code. The first thing we want to do is set an input, and then we don't necessarily want to get an input. We do need to create a definition. I'm gonna add this to the very, very top. Actually, no, we'll put it at the bottom. We'll leave it at the very bottom. Okay, so to set an input, all we're gonna do is we're gonna say, I actually just want to open this on this side, because when it starts getting with like tensor layers, that's when things get a bit complicated. We don't have labels yet. We will eventually have a layer of labels. Oh right, we changed number of inputs. We're going to change that to number of input samples. think this is, yeah, that's old code. And then number of input layers is going to be number of sample layers. I am not feeling this right now. Let's put on something a bit more chill. Appreciate everybody that's like stopped in and tuned in. We're gonna have to put some like more chill. Cool, Full Sail commercial. I'll put some more chill music on. Just had to switch it up. All right. So when we set an input, we really, what we want to do is we're just going to say append input. The first thing we're going to do, or let's just say add new input. That's what we'll do for now. Add new input. That seems to make the most sense. We're going to just take in, actually, let's break this down even further. We're going to say add new sample layer. And we're going to take in a matrix. So all we're going to do is add a single sample layer. And then we're going to just input. Going to input. We're going to inputs dot pushback, and this will probably fail. So we need to initialize this as being a tensor of size 0 with a matrix of size 0 with a vector of scalars that are size 0, 0.0f. Just so when we push something back here, we know that this is a tensor of zeros. Technically we should do this with layers too, initially. I'm not having problems out of that right now because I've already got a constructor here. And if anyone has questions, just let me know, man. The thing I don't like about this is that it's not a good way to handle this without having a 4D tensor. But we want all of our sample layers to be the same. trying to think of a way to do this safely without just like arbitrarily pushing data onto a stack. Maybe we just use it for right now. Let's just add the layer. We print the convolutional neural network, and then we add new sample layer. And then this is where we want to pass in the smiles object. And then we don't really have anything that we can use to get anything. We also didn't set our number of sample layers or number of input samples to anything. So in this case, we're just going to say that the number of input samples goes up by 1. And our number of sample layers is inputs dot size divided by the number of input samples. I don't like doing it like this because it's actually like the other way around. It would actually make more sense to do it the other way. Number of sample layers, and I would just define it simply as 1 in this. This is the right way to do it. We're going to say we're going to add a new sample. We're not going to add a sample layer. We're going to add a sample. And more specifically, we're going to say add input. Add input sample. And more than add, we're going to append an input sample. Because we're adding this to the end of the list, essentially. And then instead of it being a matrix, we really want it to be a tensor. We're going to say the input has to be a tensor because we're scaling up this tensor by this certain size. And then we can add some type safety here. We can say if the number of sample layers equals 0, then the number of sample layers equals the input size. So now we have this, we are determining that the sample layers is determined by the size of this tensor on the z-axis. And then we're gonna just, the other thing that we're gonna do is we're gonna check if the number of, if it's 0, we're gonna do this. We're gonna set the sample layer size. That means that we haven't initialized our inputs yet. Because the idea is we can append an input. Let's just change this to add, because append, and let's say new, because this is an add a new input sample. This is specifically for our inputs. We're not going to use this anywhere else. There we go. Now everything is good and well in the kingdom. So if our number of sample layers is 0, then that means we haven't done anything yet. We should really initialize this as 0 just so... Actually, we don't have to because our constructor does that. We do that at the very beginning. So once this thing is instantiated, we set it to 0. So if this is a new neural network. We don't have an input yet. If the input sample that we're putting in actually, I think a better way to do this would be to say if the number of input samples equals 0, then we haven't done anything yet, and then we can set the sample layers to be the input size. And then if the number of sample layers does not equal the input size, then we want to print error, add new input sample, error, mismatched sample sizes. We're gonna check the number of layers of your, we'll give a hint. Check the number of layers of your input data. And then we want to return. We're going to break the loop. I mess this up. Then we're going to fail. Throw an error. We'll say error. Receive mismatched sample sizes. Check the number of layers of your input data. So once the input samples is set, we're not going to set it again. We won't set any of this stuff again. Because we're only going to set it the first time. So all we're checking here is that our input samples does not equal 0. We've got one input sample at least. And that our input size matches the number of samples. Because if it's greater than 1, if it's greater than 0, we will pass this. This could be problematic if we didn't initialize this already. So I'm just gonna assume that there's a potential bug here. If you could initialize the network to have an input sample of not 0, could do something with this. You could probably overflow this buffer, but we'll skip that. I'm not going to dig into all of that at this moment. So anyway, the thing we're going to want to do is we can't push back a tensor now. We would push back each layer. We won't set the sample layers, and the number of input samples we will increase at the end of this. One time, and then we will say for int s, we'll say sample equals 0, where sample is less than the number number of sample layers, because that's what we want to check. Sample plus plus. Then we will push back a single matrix onto our array, our vector, because essentially this is a vector of matrices. So we'll push a matrix onto the input stack. And there's probably a better way to do this, but I'm gonna leave this like this for now. The only thing that we have to do for our test to work now is we have to wrap this tensor in a single matrix. See, there's no, yeah, so it's not add new sample layer, it's new add new input sample. And then that takes in a tensor size 1 that's initialized with the matrix that has smiles. So that should work. Now, as of right now, there's not really a good way of printing the input data, and I don't want to create a function that does that either. Let's go ahead and say CNN pool. They're going to create a pool function. I want to go ahead and do this. So we have our input sample. We could at least print the data here. And we're going to end up doing all of this for our convolution. So this tells us at least that we have where's our print function? Number of CNN layers. Let's add another tab to that. Want these things lined up. Minor details. So this shows us that we have one input and one layer per input. Let's change this to number of input samples. And then number of layers per sample. Cool. And then this is the number of layers. Our first layer is that. And so this is our initial function for pooling. And right now for a pooling test, so I know people would probably disagree with this, but I really don't care. Right now I'm just gonna make the pool. I'm gonna make the pool kick out a matrix. That's all I want, because we're gonna append these matrices to a new tensor. We're gonna create new tensors. And really, right now we just want the data to come out. We will work on how it how the data looks later. Because this data is going to be transformed as it's sent through the network. So our pool is going to get linked in. I can't use the term pool because it breaks my code. I have to say pooling. Okay, whatever. So far, pooling does nothing. But what I'm going to want to do is I'm going to want to print F matrix the entire thing. That's the goal, is the output of this is going to print the matrix. And we can test that by saying inputs 0. So this should kick back our matrix. And then we should have our smiley face printed. Yep. Cool. So now we know that we have our input here. We're just building this functionality for now. And this is going to get probably exponentially more complex. In my head, this seemed very simple. I don't know why. I think what I'm gonna want to do is create an anonymous function for all of these pooling functions. So I'm gonna have to look at filter and how we did this, because this is very ugly and it's gonna be how we do it. We're gonna end up doing something like this. We're actually gonna pass in a matrix. By reference. The problem with that is it's gonna create copy, so we're gonna need to make a copy. Or it's gonna transform the original data, so we're gonna need to make a copy. Some of these will be easy. I'm not sure how to do these last ones yet. None of these exist yet, so... when we run the test... When we run the function, actually, so this is in pooling. We're gonna run a pooling function. We're gonna... Right now, we're gonna... So first thing we need to do is make a copy of this. F matrix sample equals we're gonna make a copy of that essentially. And then We're going to store the values here to this, and then we're going to run the pooling function for the pooling. Where are we storing the pool type? Pool type is in... Where are we getting that from? We're going to say the input. So for right now, because this is all going to break, we're going to get the pooling data from layers 0. All of this is going to end up breaking. I already know. Get pooling data. This is funny how complex these functions get. And then we're going to get the pooling style. Then we still have to call the function. So get pooling style returns a pooling style. The pooling style is an enum, so this ends up becoming a number. So it's just an integer. That gives us the index for the function, where we can then pass the sample in by reference. And then we can just return the sample. Hopefully. Hopefully this works. So in these cases, we're not passing in a filter. We're gonna pass in a matrix. We do have a filter that we need to use also. But really, this should take place inside the class. I fucking hate this. I hate this code. Let's get it working first, and then we can put it inside the function. We really can call we could really move all of this code inside a function. We could create a F matrix function that just pooling function, and it takes in a this would actually work. We don't actually need a pointer because we're not Yes, I think we do need a pointer actually. So we're going to transform some data that we take in here. Okay, this is how we're going to do this. We're going to declare all of these here. We don't need to declare these here actually. We need to define them inside the other function. This makes my head hurt. They're never going to be called externally, so all of these can actually be inline functions. Actually, they can be static inline. This can just be inline. Stochastic pulling, RI pulling, and adapt. So none of these exist. That's fine. What we're gonna do is we're gonna create a definition for this in the pool. These are our actual pulling functions. This is where we're gonna take our input, create a copy of it. Oh shit, all of this stuff is actually inside this function. We don't have a get pulling data function. We do have a pulling style here though, so we can say that this function takes in the input, the pulling style, and then that'll work. And then we can say we just want to run. Oh, this would be hella interesting. To run the pool, we need to get the pulling data. And then for us to call the pulling function. Oh, why do we don't even need to pass in the pulling sample. What am I doing? It's already, that's why we put the function here. It's already inside of this pull instance. So we could actually get the pulling data and run pulling the function for the inputs 0. And we can actually just return this. This is kind of ugly, but it has potential. It's kind of cool to see this work actually like this. Like this is like super crazy. I'm not even using proper class inheritance either. I'm just like nesting these types inside of one another and using these anonymous functions. So none of these pooling functions work yet. None of these exist. So max pool. Ooh, this is actually not gonna work right the way that I want it. Not the way that I envisioned. So all of these take a pointer. So let's look at this. This is wrong. All of this is wrong. I'm gonna just take a pointer. And this should not pass by sample, by reference. All we just need to do is pass in the input. Fuck. Oh, this hurts my head. So we need to downsample this damn thing. Okay, we're gonna keep the sample coming in. Okay, this is a hacky way to do this, and I don't like this, but it's gonna work. It's gonna fucking work. We're gonna keep a pointer here. So we've already made a copy, but we did that because we don't want to alter the input. And then we're gonna make another copy because we don't want to overwrite the original data. So the matrix M equals, let's change this to O. O for origin. Actually, let's just make it I for let's make it input. And then just because I don't want to see all these green squigglies, we're not even going to do all of these right now. Just to make sure things are still compiling and building. Yes, we have our smiley face. We're able to run. We've got one sample. Polling test has started. Here's our convolutional neural network. We have one layer per sample. And we're going to run a stride of 2. So we should see this whole square becomes a 1. This whole square becomes a -1. Same thing for the entire top row, where eventually this square will become 0, 0, -4, and we'll keep and so on. So for the max pool, what we're going to do is we're just going to say the first thing we want to do is create a matrix. That's the data. We're going to make a copy of the input by dereferencing the input. So that's the first thing we're going to do is make a copy, because we want to push, we don't want to override our input. We don't want to change the parameters of our input because our loop is going to be based on these types of things. So our data is a copy of the input. And then we're going to say we're not even using the input dimensions in the original data type for this very reason. So for int y equals 0, where y is less than the input size, y plus plus, and then we're going to do another for int x equals 0, where x is less than input 0 size, x plus plus. And then max equals 0. We need to do float. If max is less than the input y x value, this is a matrix. The y would make it a vector, the x would make it a single float. What's your deal? Max equals input y x. Data. So we're gonna have to keep a new system here. So we're also gonna have to pass in a stride to all of these. This is gonna be really interesting. We could go back to paint on this one. My boxes aren't the same size. You'll have to get over it. The best you're getting. So our y in this case is a x of 5 and a y of 5. So 0 through 4. And if our stride is 2, then we have 3 steps. And we could divide 5 by 2. And of course, rounding it, we would have 3. But then we still have to check the if we are past this dimension. That's where you would consider padding. But there's no point in padding in a max pooling or even in an average pooling. And then the same goes for the height too. But what we can do is we can create a stride of 2. So y plus equals stride and x plus equals stride. And then we create another for loop. And I know this is a bit excessive, but this will give us the correct values in data. So we'll say for int ys equals 0, where ys is less than stride, ys plus plus. And I don't really like doing it like this, but like in terms of arithmetic, this is the simplest way. It's the most linear way, let me put it that way. I hate doing it so nested as well, but and then we end up doing y plus ys and x plus xs. And really we could say I'm a bit unsure why this matrix oh, you know why? Because this is operating as a pointer. We're still gonna have to copy this data in here. That really sucks. We need to... So what we can do is we can work from the data. And we could overwrite the input. This is actually kind of a bit cleaner though. As much as I hate doing this, we would say this is a matrix of, this is probably going to give me some problems. But I think this is going to give me problems. It would be the data size, and then these would be divided by stride plus 1, I believe. I think that's right. And then we have to uninitialize that. I still don't like doing this. What I'm gonna do is I'm gonna say f matrix cache equals this data, and then we'll store this in the cache. Value that. I mean, I don't know. Just factor in this into a value. I don't know. It doesn't matter. Cache is a matrix. This new size. Identifier X is undefined. How is it undefined? Oh, because I'm not inside the loop. So we go through a stride, and then whatever the max value is, so we don't need to do this on every Y, we need to do this on every X. We're going to set this to the max, and then at the very end we're going to set this to the cache. I hate doing it like that, but then we only ever overwrite the input at the very end of the loop. And then we can copy this to average. For average, we just plus equal, and then we divide, add them all together, and then we divide it. L2 So for each, so we're going to say that the float value equals this, and then what we're going to do is float L2 average. Oh, did I do that here? Okay, no, it didn't. Each time we take a step, we're going to reset both of these. The value, the L2 plus equals value times value. So we're going to square this by, we add them all together and then we square root the entire layer. Just to become some big values. The max global. I don't want to touch any of these yet. I really don't. The only other thing we need to do is change this to stride. Now that'll fix that. I don't know if we have to pass in a parameter name. I think that's all we have to do. And then in the convolutional layer, pooling layer, we will pass in. Oh no, in our get pooling function, we'll pass in the stride. So we're actually going to return a sample. So let's just try this. I don't know what's going to happen. Vector subscript out of range. That kind of doesn't surprise me. We did get to the end of the stride. We didn't get to the actual return of this. I imagine we're going to break in here for some reason. Yep, got this far. We're going to do max pool. I know what we did. If ys, y plus ys is less than data dot size and x plus xs is less than data dot size. So here we overstepped this last step. I didn't check for this safety measure. We only ever want to go out. We only ever want to access data ys and xs. You can see here, and that's why you get this little squiggly warning here. Sub expression may overflow. Still hit the breakpoint. So let's step into this. Oh, max value could be. We need to change that to -1, but we'll continue. We'll go ahead and step through all of it. Get more music on. As soon as I get this working, I'm gonna just call it. So I don't really care what the max or the value is. I really want to make sure that our data capacity is 13. The input size 36, so is data. Let's pin these. Data's 36. Input's 36. So each one of these is size 13. Okay, that's fine. YS. I have a feeling I just messed something here up. So any one of our data layers, for example, has a size of 13. Which kind of doesn't make a whole lot of sense, but that's the same as our input, so maybe our squiggly smiley face is actually like 13 wide and 36 tall. That would kind of make sense. So we're still going over the input size. Really, we could just... That's what we're doing. I bet you that's what we're doing. Let's try this. What happened to our breakpoint? Maybe I took it off. Input never hit. What did I change? I don't even know what I changed. Let's do a clean build. Cache dot. This is no longer a pointed reference. That was probably the only thing wrong with it. Love how it jumped past it for half a second. Oh, you know what? This is not going to work for stride again. Because what we can do is such a tacky way of doing this. God, I hate that. I almost would have rather just divided it from the get-go. So now we only want to calculate ys and xs, and then as long as xs and ys are less than, that's not as bad. That's more tolerable. Did that just equal? Damn it, XS. I did this wrong. Fuck. Take this one off. This still is not right. So this has to be done by stride. Fuck. Technically, we could still do this. We would say, let's try this. So x is 0, y is 0. Why is it hanging right? Oh, wrong button. So ys 0, So now we should go to 2. And then 3. Subscript out of range. What value did we hit? XS equals 10. Something we didn't look at was what's cache's size? Size of 7. 13 divided by 2 is 7. 13 divided by 2 plus 1. And we're counting by 2. So we gotta divide this by stride. That's where we're fucking up. Because we're counting by 2s. We gotta divide by 2. Yep. Now we've hit the next row. Let's try this again. We're close. Like we got farther than we did last time. So as of right now, we're starting our count at 0, and size counts its number based off of 1. We gotta count data size minus 1. I bet you this works. You kidding me? 12 is still valid. Why did it break right here? I don't understand. Did it break here? Did it actually break? Okay, so XS equals 10. We could say while XS is less than X plus stride and XS is less than the data size. And YS is less than the data size. And then at this point, we don't need that. We're gonna run that check every time anyway. At least lower the redundancy. So XS is 11. Like already was 11. Set 1. Data size is set 12 now. Say XS is set to 12. We can access this value. That's where we messed up. Because we run it after. We need to run it before. I don't know if this will make any difference. Yep. We can say -2. I really think maybe running it before will make a difference. We could run the initial data size -1 on X and Y. It'd be cool to see this change once we get it working. We hit 13, we get the overflow. So it's gonna have to be -2 because we're gonna do the check. I bet you this whole thing worked now. Still failed. Great. Kidding me? Why is it still going to 13? Oh, I'm so dumb. It is data size 0. You know what? We're gonna do int input width equals input I was looking at the wrong dimension. Input with input height and then input height. Input width and then input height -1 and input width -1. God, I feel stupid. And here you can see it counting by 2s in the X. And then counting by 1s inside our range. So we hit 14, we skip down to the next row. We start this all over again. If we take off all of our breakpoints now, we still hit a freaking overflow. Because we could go over by 2. I don't think this is going to be exactly right, but let's see what y gets to. If it gets to 14, we've messed up. If it gets to 15, we've messed up. Oh, that's what it was. And that's not right because 36 divided by 2 should be 18. This is the height. This is the width. I got them backwards. So 36 should be 18. And then 13 should be 7. Maybe we could say +1 divided by stride. And +1 divided by stride. Let's try that. That might be better. 36 divided by 2 should be 18. $36 and 13. Cash is now 36. Oh, because I did 1 divided by stride, which is 2. It ends up being weird. So now our cache ends up being size 18 by 7, so that's right. If we take this off, do we get output? Hey. All of these rows are wrong though. I'm not quite sure why. Because we didn't use that last row. Can we just say it's less than the input width now? This is close. Going over. It's kind of cool though. That max value shouldn't be there for the last field though. We're never actually hitting that stride. Oh, you know what it is? These are right. We don't need to go less than the width and the height though. We're just destroying data essentially. There we go. And then now we can update all of this. This is how we need to calculate things from now on. And then we can try to set full type to have average pooling. Let's see what that does. What did I do? Ew. Hmm. Well, it worked in the other one. Shouldn't be zeros here. We never hit the last row. Why is that? Hmm. What did I miss? What did I... Oh, because I'm initializing this to 0. Does this still need to be 2? Because I can hit... No. Maybe it just needs to be less than the width. How does that work? Oh, this should be 0. I shouldn't be adding any... I shouldn't start with the negative bias. Should start with the 0. And then the average... Oh, so this... int average counter equals 0. Average counter plus plus, and then boom. That one was going through and it was dividing it by 4, even though we were only counting 2 values. Interesting stuff, man. Kinda cool. Kinda cool. Alright, well, some of this works. I'm gonna take a break for a while. Gonna get dinner and such. Appreciate everybody who's tuned in and watched. I'm gonna probably finish the rest of these pooling styles on my own for the time being. I'll catch up with you guys later. I appreciate you guys tuning in. And, yeah. We'll see you later.